All right, picking up where we left off with y-axis symmetry, we know that in order to be symmetric to y-axis, we have to have, for every xy, there is a negative xy on the graph. So that means that we need to replace x with negative x and get the same equation back again. So we've got our two pictures here. Let's look at what happens if we have an equation. So let's try y equals 2x squared. All right, so to check this one, for y-axis symmetry, we're going to replace x with negative x. So that's going to look like that. All right, now remember order of operations. The square only goes with the x. It does not go with the 2. So we've got negative x squared, and like before, that's going to be negative x times negative x. It's going to come out positive. So we're going to have positive x squared times 2. Positive x squared times 2 will be 2x squared. Did we get back to what we started with? Yes, so we are symmetric to the y-axis. All right, and the picture looks a lot like this first picture right here. Okay, so we can see it as a graph and we can see it as an equation. All right, the last one that we're going to do is a little bit different, and it is symmetry to the origin. And symmetry to the origin is not a mirror symmetry. There are two different ways that you can look at it. You can look at it as a double reflection. Okay, a double reflection around x and y, and it doesn't matter which order you do that in, x then y or y then x. Or you can think of it as a rotation of 180 degrees. Okay, so you can either think of it as a double reflection or a rotation. Okay, so let's look at an example. We're going to do some more of these in class, but this is just one example to get us started with, because this one's a little bit harder to see. See if I can make this look right. Okay, there we go. So this is our example graph. All right, this one is symmetric to the origin. So to see that, let's just look at half of the graph. All right, so let's just look at the right side and see if we can see the image that it creates on the left side. So if I use I'm going to use light blue here. So we can either reflect it around x and then y, or y and then x. So first, let's go around x and then around y. So when we reflect this around x, it's going to go like that. Okay, that dotted blue line is going to be the reflection of the red graph. And then when we reflect that around y, it's going to go across the y-axis like that. So reflection around x gives us this, and then reflection around y gives us this. So our final location is that, which is the original graph. Okay, we can also see it going around y and then around x, and we'll get the same thing. So x, y, looking at just half of the picture. Okay, this time we'll use light green. So if we reflect it around y first, oh, that looks a little bit off. Let me fix that. Okay, there's reflecting around y first, and then reflecting that around x. We get that. So our final location is right here. Okay, so whichever way we reflect it, we end up in the same place. Okay, the other way to look at this is as a rotation. This is going to be a little bit harder for me to show you guys on a screen. So we'll talk about this one in class as well. Okay, so we start with that. So to look at it as a rotation, what you have to do is you have to take this, like this is your piece of paper. Okay, pretend that you cut your piece of paper, and then you're going to rotate it 180 degrees to that side. Okay, or you can picture it rotating that way. All right, so we're going to rotate it 180 degrees, whichever way you picture flipping that. And when you rotate it around, you should see that it's going to land over here when you take that piece of paper around. So you're going to spin it around the origin, and it's going to land there. Okay, so that's looking at it as a double reflection or a rotation of 180 degrees. Okay, so when we look at the equation, so that's how we look at it in graph form. When we look at it in equation form, the way that we're going to look at the equation is as a double reflection, because we know what happens when we reflect around x, and we know what happens when we reflect around y. So let's say that we start with this point right here. Okay, let's say this is our xy. All right, so what happens when we reflect around x? When we reflect around x, well, we know what happens. Our x stays the same, and our y changes signs. Okay, so whatever sign our y was down here, it's negative now. So let's say this is 2, -1. Okay, so in our image, it's going to change signs to -1, which is +1. Okay, so our y changes signs when we reflect around x. Then to reflect around y, our x changes signs. So we're going to be at -2, 1. Okay, so for this point right here, 2, -1, its image is at -2, +1. At -2, +1. So the reflection around x changes the sign on y. The reflection around y changes the sign on x. So for every point xy, so we pick any point out here, xy, its image is going to be -x, -y. Okay, so that gives us our definition for origin. For every xy, there is -x, -y on the graph. So this time we need to replace x with -x and y with -y at the same time. So the same thing that we saw before, but we're replacing both of them. So we're going to replace x and -x and y and -y. Okay, so looking at equations to test them with symmetry to the origin, we're looking to replace xy with -x and -y at the same time. So let's say we have y is equal to x cubed. Okay, so we're going to replace y with -y, and we're going to replace x with -x. Okay, so on the left-hand side we have -y. There's nothing we can do with that. On the right-hand side we've got -x cubed. So if we simplify this like we did before, we'd have -x times -x times -x. So remember, pairs of negatives cancel out, but we've got an odd number here. So this is going to come out negative overall, and then x times x times x is x cubed. So -x cubed is the same as -x cubed. Okay, so for x cubed, that negative can come out front. Now this is not the same as what we started with, but remember our trick, if it doesn't match exactly, we can multiply through by a -1. That changes all of the signs, and we do get what we started with. So this is symmetric to the origin. Okay, and that's it for symmetry. We'll go through an example in class that runs through all of these together. So if it's not 100% clear, that's okay. Sometimes it helps to see it twice.